Okay, we are back for a much shorter segment, so check your answers in number 8. So notice base, right? Base is here. The exponent is the answer. All right, so that's how we get this set up. And for these log equations, so let's see, I had already done this one with you, x equals 81. Here you have to ask yourself, what power do I raise 16 to get 4? Okay, well, the square root of 16 is 4, but I have to write that as a power. All right, which square root we should know is the 1/2 power. And I hope you know your perfect cubes well enough to recognize that I would have to cube 2 to get 8. All right, so we should know our first few perfect cubes. We should know all of our perfect squares. Again, we reviewed that earlier in the year. Now, I always teach my education students how important compare and contrast is, all right, because it would be very easy to mix up our exponential functions with power functions. All right, power functions we've been working with earlier in this semester. These are all polynomials, but if it's just x to some power, right, and that's it, there's no other terms, then it's called a power function. Right? They're still polynomials, but they're also can be labeled as power functions. So we don't want to mix up, right? There's a big difference between x squared versus 2 to the x, right? Which is an exponential function, right? So it's very easy to mix these up, all right? So pay close attention to the fact that for a power function, the variable is the base. Okay, for an exponential function, the variable is the exponent. Okay, so over here I have a variable for a base, a constant for an exponent. Here I have a constant for a base, a variable for an exponent. All right, so spend a minute labeling A through F. All right, so pause the video and get those labeled. All right, so I'm labeling P for power, EX for exponential. Remember, exponential can be exponential decay or growth. This is a power function, so x to the 1/2 is still a power function. And that's exponential, and that's power. And then on to some prerequisite skills for the next section. All right, some exercises with percentages. And you're asked, all right, so you earn $50,000 a year and you get a 2.5% raise. Find your new salary using a one-step process. I bet all of you can easily do this, but you would use a two-step process. All right, okay, because I know what you would do is you'd multiply this by 0.25, because you'd have to change that to a decimal. You'd find the amount of the raise, right? And so you'd say, okay, so my raise is this certain amount, and then you would add it on to the $50,000. And I want you to do this in a one-step process, all right? Because if you get a 2.5% raise, what you really have is you have 100% of what you've been earning. You still get the 100%, but then you also get 2.5% more. Okay, so look what would happen then if I wrote this as 102.5%. Right, change that to a decimal, and I would get 1.025. All right, then I could multiply by the 50,000. I'm just going to write 50K. Okay, 1 times 50K, because I could think of this. I could also think of this as putting a plus sign here and putting the decimal point right here. All right, 1 times 50K is the 50K. Here is the 0.025 percent of the 50K, which is the raise. All right, but I've done it all in one step. Okay, so just multiplying 50K times 1.05 would allow me to find that new salary in one step. Okay, so if I got a 3% raise and I made 50K, right, you would do 50K times 1.03 because you get 100% of your pay plus the 3%. All right, then the final thing that we have to do for prerequisite skill that we're going to review is percent increase. All right, so a formula for percent increase is the amount of increase, and this is the same formula for percent decrease, right? I would just replace the word decrease with, or increase with decrease. All right, the amount of increase divided by the original amount. All right, so notice when we do percent of increase, we always compare to where we start, right? The original amount. So your 42,000 salary increased to 4,300, 500. So we always compare to where we started, right? Our starting point. So then the percent increase is the amount of increase, which is 1,500, compared to the 42,000, and then we convert that to a percentage. So let me get out my calculator and divide. All right, and so I got about, like I get this. It's not perfect, but in real life, seldom do we get nice round whole numbers. I don't know why I'm saying it's not perfect. It's not a round number. But then I would round it, maybe I'd call that about 3.5%. About 3.5. All right, and then other than the participation assignment for today, then you are done with your videos for today's exercises.